Welcome back to the second part of motion in a plane, previous year NEET questions. So without any delay, let me start. So look at the first question. So now today's concept is based on projectile motion. Super. So projectile is motion is a combination of uniform and non-uniform motion. Horizontal motion of the particle is uniform, vertical motion of the particle is non-uniform. I just divided this into two different types of processes: horizontal component of velocities and vertical components of velocities. I'll show it while I'm solving numericals. I'll make it easy for you to solve this. Look at this. So question number 25. A projectile is fired from the surface of the earth with a velocity 5 meter per second and angle theta with horizontal. Okay, so projectile is fired from the surface of the earth with an initial velocity 5 meter per second at an angle theta. Okay, next, another projectile fired from the another planet with a velocity 3 meter per second. Okay, another particle is fired from the another planet with a velocity 3 meter per second at the same angle or a different angle. At the same angle follows a trajectory which is identical with the trajectory of the projectile fired from the earth. That means the path of this projectile is the same as path of the projectile which is fired from the surface of the earth, like this. So this is going to be the range and this is height h. Similarly, if you project a particle from the another planet also, this is h and this is going to be r. There is no any change in these values because the path, the trajectory of this particle is the same in both the cases. Can I say range of the projectile is same in both the cases because they said trajectory is the same? So that is the reason I am taking range as same. Let me consider range as same. What's the formula for range of a projectile? Range of a projectile formula is r is equal to u square sine 2 theta by g. As range is same, I can write it down. It is as range on planet, range on earth and range on planet, both are same. So this is earth and this is planet. So as this is second object is another planet, acceleration due to gravity is going to be different. So from this only thing I can decide is range is same, theta is same. As theta is same, sine 2 theta is also same. G and u are the only values which are different. They are asking, what is the question they are asking? They are asking the value of acceleration due to gravity on the planet. Okay, so acceleration due to gravity is directly proportional to speed with that object is being projected, square of the speed. So acceleration due to gravity on the planet divided by acceleration due to gravity on the earth is equal to velocity with which object is projected on the planet square divided by on earth square. So acceleration due to gravity on the planet is equal to velocity on the planet square is 3 square, it is going to be 9 divided by ue square, it is going to be 25 into g value approximately I am going to take it as 10. Actually in the question they have given g is equal to 9.8 meter per second square, but I have read approximated it to 10. Did I increase or decrease the value of acceleration due to gravity? I did increase. If I increase the value of acceleration due to gravity, whatever the acceleration due to gravity on the planet, that I am going to get the answer is little more than the actual value of acceleration due to gravity. Acceleration due to gravity on the planet is equal to 25 ones are 25 0.4. 0.4 into 25 is nothing but 10. So it is going to yes, it is 9 into 0.4, it is going to be 3.6. So this is the answer I got, but actually answer should be less than 3.6 or more than 3.6. It should be less than 3.6 because I've increased 9.8 to 10. That is the reason actual answer is G planet is equal to 3.5. Answer is more than what I have to get. Okay, next question. Question number 26. Solution. So in a projectile motion, which component of velocity is going to be horizontal component of velocity or vertical component of velocity? Horizontal component of velocity is going to be constant. So if any object is projected with some velocity u, horizontal component of velocity in projectile motion is always the same because horizontal acceleration is 0. Remember this point. Note. First point, horizontal acceleration is equal to 0. So horizontal velocity in projectile motion is equal to constant. Second point, vertical acceleration is equal to acceleration due to gravity. So vertical velocity is going to be variable. First it will reduce us to 0 and then it will increase us to the value, whatever the value with which you are going to hit it. Okay. Let me consider object is being projected with a speed u. Now at an angle theta. Let me divide this into two components, horizontal component of velocity and vertical component. Horizontal component of velocity is going to be u cos theta. This can be replaced as ux. Vertical component of velocity is going to be uy is equal to u sin theta. Here ux is horizontal component of velocity. Horizontal component of velocity. So whereas uy is vertical component of velocity. Vertical component of velocity. So which velocity changes? Definitely vertical component of velocity changes. That is the reason object will undergoes a parabolic path like this. Okay. Now when it reaches maximum height, which component of velocity will become 0? Vertical component of velocity is 0. Horizontal component of velocity is going to be constant, which is equal to u cos theta. When it is hitting the ground, horizontal component of velocity is constant, that is ux is equal to u cos theta. Vertical component of velocity direction changes, which is equal to uy is equal to u sin theta. So if you observe here, the velocity with which that object is being projected, that is initial velocity is equal to u cos theta I cap plus u sin theta j cap. This is the velocity with which object is being projected. So if final velocity is equal to final velocity with which it is going to hit the ground is represented as v final, or you can write down, okay, let me represent it, v final itself. So initial velocity simply I am representing with u, v initial. V final is equal to u cos theta I cap, but vertical component of velocity is going to change its direction, that is u sin theta j cap minus you are going to get. Try to understand the difference. So which component of velocity changes when it is hitting with the ground? In a projectile motion, vertical component of velocity changes. First it will reaches to maximum, then when it reaches to the ground, it will hits the ground with a negative velocity. Hope you understand. Point of projection of velocities at A and B are represented here. Now observe this question. Question number 26. They said the velocity of a projectile at initial point A is 2 cap plus 3 j cap. Its velocity in meter per second at point B. At point B is nothing but point of the position at which object will hit the ground. Okay. So initial velocity they have already given, that is 2 cap plus 3 j cap. What is going to be final velocity? Which component will changes? Vertical component or horizontal component? Horizontal component of velocity is going to be constant. Vertical component of velocity direction changes, that is minus 3 j cap. This is the answer for the given question and this is the proof. Hope you understand which option is correct. Option 2 is correct. Let's see question number 27. In this question they said the horizontal range and maximum height of a projectile are equal. Okay, 27. Horizontal range and maximum height both are same in a projectile. So range formula is u square sine 2 theta by g. Height formula u square sine square theta by 2g. They said both are equal. Okay, then what should I have to find out? The angle of projection of the particle. Okay, so u square g will get cancelled out. Sine 2 theta can be written as 2 sine theta cos theta, which is equal to sine square theta. So by 2 will be there. So sine theta will get cancelled out. Send this cos theta right side, it will become sine theta by cos theta is equal to 4, and tan theta is equal to 4, and theta is equal to tan inverse of 4 is the answer. If range is equal to height of the projectile, answer is going to be theta is equal to tan inverse of 4. Next, question number 28. A missile is fired for maximum range with an initial velocity of 20 meter per second. If g is equal to 10 meter per second, range of the missile they are asking. Okay. Theta at which angle of, that means angle of projection at which range is going to be maximum is theta is equal to 45 degrees. So look at this. What's the formula for range? R is equal to u square sine 2 theta by g. At what value of theta r is going to be maximum? Theta is equal to 45 degrees. Then r maximum is equal to u square sine 2 into 45 divided by g. So 2 into 45 is going to be 90 degrees. So sine 90 will be equal to 1. So maximum value of range is going to be u square by g. So the velocity with which object is projected or fired is 20 meter per second. Okay, then r maximum is equal to 20 square divided by value of acceleration due to gravity 10. So it is going to be 400 by 10 and it is equal to 40 meter. Which option? Option A is correct. Very good. Next, question number 29. Solution. Okay, so a projectile is fired at an angle 45 degrees with a horizontal. Okay, let me represent that. What is the angle with which a projectile is fired? 45 degrees. Okay. Elevation angle of the projectile at its highest point seen from the point of projection. Okay, they are asking elevation angle. The meaning of elevation angle, angle made by the starting position with respect to maximum height. Okay, let's say this is the maximum height. Now I need angle of elevation. Look at this. This is how angle of elevation is represented. This is what I need, theta. So first of all, find out height. That means maximum height. And the range. If we can find out range, so the side, this side is going to be half of the range, that is r by 2. Now how to find out angle? They are asking angle of elevation. This theta is called as angle of elevation. Angle made by the line which is touching starting point and the maximum point with respect to horizontal x-axis, y-axis. So what about tan theta? Tan theta is equal to h by r by 2, right? So 2h by r is the formula. So what's the formula for h? H is equal to u square sine square 45 degrees by 2g. divided by range formula u square sine 2 into 45 divided by g. U square by g will get cancelled out. Sine 90 is equal to 1. So I am left with this 2 will get cancelled out. Sine square 45. So tan theta is equal to, for sine 45 is 1 by root 2. Then 1 by root 2 square is going to be 1 by 2. This is what I am going to get. Then theta is equal to tan inverse of 1 by 2. This is the answer. This is the angle. It is called as the angle seen from the point of projection. Okay, hope you understood. Is it clear, guys? Yes. Question number 30. In question number 30, the speed of a projectile at its maximum height, they are asking the speed of a projectile at its maximum height is half of its original speed. Okay, now observe the representation. Let's say a particle is projected with an initial speed u. X-axis and y-axis. So let's say it is theta. When it is at maximum height, so what's the horizontal component of velocity? It is going to be ux is equal to u cos theta. Vertical component is equal to vuy is equal to u sin theta. Okay. So horizontal component of velocity is going to be constant throughout the projectile motion because horizontal acceleration is 0. Vertical component of velocity is going to be reduces to 0, then increases to maximum value. So when at the maximum height, only horizontal component of velocity present, that is equal to u cos theta. Vertical component of velocity is equal to 0. Okay, so what is the point? They said the speed of the projectile at its maximum height. So if you observe here, so speed is nothing but ux is equal to u cos theta at the maximum height. General representation of the speed at this point. So speed at maximum height is equal to ux I cap plus uy j cap, magnitude of velocity, which is equal to, so we have to find out magnitude. Actually this is not a speed, it's actually velocity at maximum height. So this is velocity at maximum height. Now I need speed at maximum height. Speed at maximum height is nothing but here uy is equal to 0, then root of ux square, square root will get cancelled, which is equal to ux. That is going to be speed at maximum height. So speed at maximum height, it is u cos theta, which is half of the initial speed. What is the initial speed here? So initial speed, they are not asking velocity. Initial speed is equal to u. Initial velocity is different. Initial velocity, if they ask you initial velocity is nothing but components out. That is u cos theta I cap plus u sin theta j cap. This is the representation of initial velocity. So they clearly mentioned that speed of the projectile at maximum height. What is the speed of the projectile at maximum height? U cos theta, which is equal to half of its initial speed. Initial speed is u, half in the sense by 2. So u get cancelled, then cos theta is equal to 1 by 2. At what value of theta you are going to get cos theta 1 by 2? At 60 degrees. Which option is correct? Option A is correct. Very good. Next. Question number 31. In question number 31, a particle of mass m projected with a velocity v making an angle 45 degrees with horizontal. Okay. Particle's mass m is projected with a velocity v making an angle 45 degrees with a horizontal. Okay. When particle lands on the level ground, magnitude of change in momentum, magnitude of the change in its momentum will be, okay. So what is the initial velocity? First of all, find out that it is going to be v cos 45 next v sin 45. Mass of the particle is m. First of all, find out initial momentum. Initial momentum is equal to mass into initial velocity, which is equal to m into v cos 45 I cap plus m into v sin 45 j cap, which is equal to mv by root 2 I cap plus mv by root 2 j cap. This is initial momentum. Next, final. When it hits the ground, look at this. When a projectile hits the ground, which component of velocity is going to be 0? No, nothing. So when it is at maximum height, vertical component of velocity is going to be 0. Horizontal component of velocity is going to be present. Horizontal component of velocity is equal to v cos 45, which is present. Now when it is going to hit the ground, horizontal component of velocity will be constant, which is equal to v cos 45. Vertical component of velocity will be increases to initial value. So when vertical component of velocity when it is at maximum height is 0. Vertical component of velocity when it hits the ground is minus v cos, not cos, it is going to be sin 45. So let me represent in terms of notation of vector. So p final momentum is equal to m into v final. So which is m into v final is v cos 45 I cap minus v sin 45 j cap. Why minus? When it is hitting with the ground, vertical component of velocity is going to be negative. Okay, so finally it is m v cos 45 is nothing by root 2 I cap next minus mv sin 45 by root 2 j cap. So they are asking magnitude of change in momentum. So this is the final momentum with respect to initial and final. Change in momentum is equal to final momentum minus initial momentum. I need only magnitude. That is what they are asking. Final momentum is mv by root 2 I cap minus mv by root 2 j cap. Next, minus final velocity minus initial minus mv by root 2 I cap minus mv by root 2 j cap. So mv by root 2 I cap, mv by root 2 I cap will get cancelled out. I am left with minus 2 mv by root 2 j cap. This is change in momentum vector notation. Okay, so if I need only magnitude, I can represent it as so 2 can be written as root 2 into mv by root 2. Root 2 will get cancelled. So change in momentum magnitude is root 2 times of mv. Next, hope you understood. So which option is matching? Option A is correct for this question. Okay, let's get into the next one. So 32. So before solving this 32, so let me give you one hint. Note, if any particle is projected at an angles theta and 90 minus theta, then the ranges of their projectile the projectiles are same. Remember, are if sum of angles of projections of a particle is equal to 90 degrees, then ranges of the projectiles are same. Hope you understand. Remember this point. If angle of projection, so sum of the angles of projections are equal to 90 degrees, then the ranges of their projectiles is going to be same. Remember this point. Okay, look at the question. So for angles of projection of a particle at an angle 45 minus theta and 45 plus theta, the horizontal range is described by the horizontal range described by the projectile or in the ratio. They're asking ranges ratio. Okay, so definitely it is going to be same, right? Because whenever sum of the angles is equal to 0, sum of angles of projections of a particle is equal to 90 degrees, then ranges are same. Okay, so let's use this point. So with the help of this point, answer is going to be option B. Let me prove that question number 32. Let me prove that with the help of equations. Let's say one particle is projected with an angle 45 minus theta. So what's the formula for range? Range is equal to u square sine, what's the formula? U square sine 2 theta by g, right? Let's say r1 is equal to u square sine 45 minus theta is nothing but 90 minus 2 theta divided by g, correct? So what is 90 minus theta? 90 minus theta is going to be cos theta, plus cos theta or minus cos theta, plus cos theta. You are going to get r1 is equal to u square cos 2 theta divided by g. This is the range of the first projectile. Okay, let's see range of the second projectile. What's angle of projection? Angle of projection is going to be let's speed u. It is going to be 45 plus theta. So don't imagine this value as 4. It is u, initial velocity. Now in this case, r2 is equal to u square sine 2 theta divided by g. So what is the value of theta here? 45 plus theta, right? Then u square sine 2 theta, 90 plus theta divided by g. So what about 90 plus theta? Sine 90 plus theta is equal to cos theta. So it is going to be u square cos 2 theta by g. So if you observe in both the cases, is r1 is equal to r2? Yes, it is. Range of the projectile is going to be same. So if this solution is following the point that I have given, range r1 is equal to r2. When it is applicable, if sum of the angles of projections are equal to 90 degrees. If sum of angles of projections are equal to 90 degrees, then this is applicable. Try to understand. Very good. Let us see the next question. Look at question number 33. By seeing question itself, students used to feel like it is going to be a difficult question. Don't decide like that just by seeing it. Just read it, then we'll decide how it is going to be difficult. Okay. So a particle A is dropped from a height and another particle B is projected in horizontal direction with a speed 5 meter per second from the same height. Okay, super. Question number 33. So one particle is dropped. Let's say particle A is dropped from a height. Let's say it is going to be h. I am imagining. So it is dropped. Dropped in the sense initial velocity is equal to 0. Okay. So from the same height, another particle is projected in a horizontal direction. It is projected with a velocity 5 meter per second. Then what's the question they're asking? They're asking which of the following statements are correct. Okay, particle A will reach the ground first with respect to particle B. So the thing they're asking is which particle may reach the ground first. Okay, so this is the ground. Check out what are the initial vertical velocities of both the objects in both the cases. So as object is projected along horizontal, vertical velocity is going to be 0. Here in section the first case, object is being dropped, so initial vertical velocity is equal to 0. As height is the same, I think they are going to reach the ground in the same time. Let us see how. So formula S is equal to ut plus half a t square. This vertical component of velocities I have to consider sy ay. Initial vertical velocity of both the cases is going to be 0. Then S is equal to 1 by 2 into gt square. S is represented as a negative, that is you can write down it is as minus h, and minus h and minus g in minus will get cancelled. So you are going to get h is equal to 1 by 2 g t square. Is height is the same for both the cases? Yes, it is same. As height is same, then time is also same. Nothing is going to change here. You just have to observe initial vertical components of velocities of both the objects. So initial vertical components velocities of the both the objects are equal to zeros only. That is the reason time taken by the projectiles is equal to 0. So and one more thing I will give you that hint, make it as a note. In projectile motion, so this is for in projectile motion. In projectile motion, horizontal components of velocities, horizontal components of velocities are used to find range. Range of the projectile. Whereas vertical component of velocities are used to find the time of flight. Vertical components of velocities are used to find time of flight. Remember, these are used to find time of flight. Hope you understood. So remember these 2 points carefully. Horizontal component of velocities are responsible for range. Vertical components of velocities are responsible for time taken by the projectile to reach the ground. Let's get into the next problem. Question number 34. In question number 34, so which option is correct? Here it is option both particles will reach the ground simultaneously for question number 33. Okay, next. 2 particles of same mass and with the same velocities are thrown at an angles 60 degrees and 30 degrees with the horizontal. Then they will remain same in. So which is going to be same? Range of the projectile is same. Just now we have given this point. Here it is. Just go through that point. If range of sum of the angles of projections are equal to 90 degrees, then ranges are equal. Now in this case they have given one angle is 60 degrees, another angle is 30 degrees, which is equal to 90 degrees. As sum of angles is equal to 90 degrees, range is going to be same. I have given proof also. Next. So hope you understood. So 60 plus 30 degrees, which is equal to 90 degrees. So ranges are equal. Sum of the angles is equal to 90 degrees. Next. If a body A of mass capital M thrown with a velocity v at an angle of 30 degrees to the horizontal, another body p of same mass is thrown with the same speed at an angle 60 degrees to the horizontal. The ratio of horizontal range of A and B is again same answer. What is this? What is this answer, ma? Think you're going to get 1:1, right? Yes, it is. Why it is 1:1? Angles of projection again 30 degrees plus 60 degrees, which is equal to 90 degrees. Answer is going to be 1:1. So just try to understand how many times this type of concepts are being repeated. Only one point you have to remember is if sum of angles of projection are equal to 90 degrees, then answer is going to be 1:1. That means the range of the projectile is equal to 1. Super. Ratio of ranges is equal to 1. Next, question number 36. Let us see how to solve it. 36. Maximum range of a gun of horizontal terrain is 16 kilometer. Okay. Maximum range is equal to 16 kilometer. When range is maximum, what's the formula for range? Range is equal to u square sine 2 theta by g. At what value of theta you are going to get maximum range? R maximum is equal to u square by g at theta is equal to 45 degrees. So theta range will be maximum only at theta is equal to 45 degrees. Okay. Now what's the question they're asking? If g is equal to 10 meter per second square, then the muzzle velocity of a shell must be. So they're asking velocity from this equation. What's the value of R maximum they have given in the question? R maximum is equal to 16,000 kilometers. 16,000 kilometer, which is equal to u square by the value of g is 10. Then u square is equal to 16,000 kilometer. The options they have given in terms of meter per second, right? If they have given in terms of meter per second, let us see how to convert them. Sorry, a small substitution mistake here. How much value of R maximum they have given? 16 kilometer. 16 kilometer can be converted as 16,000 meter. Then u square is equal to 16,000 meters. Then u is equal to root of 16 into 10 power 4 you can write on. Then you can write it as 4 into 10 square. So u is equal to 400 meter per second. This is the answer. Question option C is correct. Okay, let's solve next concept questions. So next concept is uniform circular motion. Okay. So one thing I would like to mention. So before solving this numericals, uniform circular motion. In uniform circular motion, velocity of the object which is moving in a circular motion is going to be constant. So that is the reason we call it as a uniform circular motion. I would like to give one important point. So all the points required in circular motion, I will give it here itself. Try to understand each and every point. So whenever a particle is moving in a circular motion, let's say radius of the circular motion is r. Let's say it is moving with an initial velocity v. So here, whenever particle is moving in a circular motion, definitely there will be a centripetal force. That centripetal force is the responsible force for that object to move in a circular motion. So that is called as Fc, which is equal to mv square by r. So what is the meaning of Fc? Fc is equal to centripetal force. What's the meaning of centripetal force? Which makes the particle move in a circular motion. Okay, so on the formula for centripetal forces is mv square by r, where m is mass of the particle, r is radius of the particle moving in a circular motion. Then what about centripetal acceleration? Centripetal acceleration is equal to Fc by m, which is equal to v square by r. This is the centripetal acceleration acting on that particle. So when particle is moving in a circular motion, tangential acceleration is equal to 0. So then only velocity of the particle moving in a circular path is going to be constant. Otherwise it is going to change. It is going to be changed. If it is changed, that is not going to be uniform circular motion. Then that is going to be non-uniform circular motion. Very good. So actual relative formula is d magnitude of v by dt. So here tangential acceleration is equal to 0. Only centripetal acceleration is present, which is responsible for motion of the object in a circular motion with a constant velocity. Okay. So let's say I'm assuming particle is at here. Particle is moving in anti-clockwise direction with a constant velocity v. Radius of the circular path is r. So position vector is represented like this, and angular velocity of the particle is represented as, or else we can write it down as omega. V bar is equal to omega bar cross r bar. So this is the relation between linear velocity and angular velocity. Relation between linear and angular velocity. Linear and angular velocity. So in this case, as omega and r are perpendicular with each other, you can write it down as v is equal to r omega. So relation between linear velocity and angular velocity. When particle is moving in a circular motion, theta is represented in out of the board. Theta is an axial vector which acts away from it. So I'll represent it like this. You can find out direction of theta by using right hand thumb rule. Okay, so angular displacement, theta is equal to angular displacement. Let me consider anti-clockwise direction. So particle is at a distance r. Let us say it is moving in anti-clockwise direction. Then theta is going to be out of mobile. So if a particle is moving in a clockwise direction, radius r, if it is moving in a clockwise direction, then theta is going to be into the mobile phone. This is the point you have to remember. So what kind of direction? For anti-clockwise direction, theta is out of the board. For clockwise direction, theta is into the board. Remember this point. Now let's solve numericals based on this. V is equal to r omega. Remember the relation between linear velocity and angular velocity is v is equal to r omega. Okay. Question number 37. Look at the data what they have given. Two particles A and B are moving in uniform circular motion in concentric circles of radius RA and RB with speeds VA and VB respectively. Their time periods of rotation is the same, and the ratio of angular speed of A to that of B is okay. The time period of rotation is the same for both objects. So what's the formula for a time period? Time period is equal to 2 pi by omega, right? Does time period depends on radius and velocity of those objects? No, it is not. So I am representing here. So it is independent of radius and velocity of the object. So it depends only on angular velocity. So you can write it down as t is inversely proportional to omega. As t is same in both the cases, omega is also same, and ratio is going to be 1:1. That's all. Next, a particle starting from rest. Previous question, option A is correct. A particle starting from rest move in a circle of radius smaller. Okay. Question number 38. It is moving in a circular motion. Starting from rest, it attains a velocity of v0 meter per second in nth round. Okay. So let's say radius is smaller. Initial v initial is equal to 0. It is initially at rest position. Mass of the particle is, let's say, m. Did they give mass? No, they haven't given. No need. Okay. So it attains a velocity of v0 meter per second in nth round. Then they are asking angular acceleration. What's the formula for angular acceleration? Angular acceleration is equal to, there is a relation between tangential acceleration and linear acceleration. Tangential acceleration at is equal to r alpha. Relation between tangential acceleration and angular acceleration. First of all, let me find out tangential acceleration after nth round. So for every one round, what is going to be the distance covered by this object? It is going to be 2 pi r, right? Okay. So what is the initial velocity? Initial velocity is equal to 0. Final velocity is equal to v0 after how many rounds? After n rounds. Okay, let me find out tangential acceleration by using v square is equal to u square plus 2as equation. So as there are n rounds, you have to multiply it with n also. Initial velocity is equal to 0. Final velocity is v0 square, which is equal to 2 into acceleration is 80. That's what I have to find out. Into displacement in nth. So for every one cycle, what is the distance covered by that object? So look at this. So by the time it completes one circular motion, it covers a displacement of 2 pi r. So red color one only, observe that it is equal to 2 pi r. This is called as circumference of a circle. Then, which is equal to 2 pi r. How many rounds it is traveling? It is traveling n rounds. It is travels. Now I need tangential acceleration. Tangential acceleration is equal to v0 square by 4 pi r n is the tangential acceleration. Do we need tangential acceleration or angular acceleration? I need angular acceleration. What's the formula for angular acceleration? At is equal to r alpha. So from this r is equal to radius of the circle. Then you have to represent it here as a smaller. Okay, so here it is a smaller, not capital R. Then at is equal to v0 square by 4 pi r n is equal to r into alpha. Then alpha is equal to v0 square divided by 4 pi r square n. This is the answer. Look at the option which is matching. v0 square by 4 pi r square n. Option C is matching. That's the answer for this given question. Okay, let's move on to the next question. Look at this question number 39. What's they're asking? Question number 39. I given different diagram. Okay, so it's a circular motion and the particle is moving in a circular motion. So whose velocity we don't know. It is moving in a circular motion. So let's say radius of this circular motion is equal to r. And then this is the diagram they have given. Let's say this is A and this angle is equal to 30 degrees. Okay. First of all, let me read out the question. In the given figure, A is equal to 15 meter per second square. Okay, so this value of A they have already given. This A is nothing but actually net acceleration. So A is equal to 15 meter per second square. Super. That represent the total acceleration of the particle moving in a clockwise direction in a circle of radius r is equal to 2.5 meter. They are given this value 2.5 meter. Super. At a given instant of time, the speed of the particle is, they were asking at the given instant of time, speed of the particle is. Okay, so What's the direction of centripetal force? Centripetal force is always towards the center of the circular motion, right? So I know the value of net acceleration. With the help of net acceleration, let me divide that into two components. Then component towards the center and along the centripetal acceleration, AC is equal to A cos 30. Very good. What's the value of A? A is equal to 15. Cos 30 is root 3 by 2, which is equal to 15 root 3 by 2 is the centripetal acceleration. Do we know the formula for centripetal acceleration? Yes, we know that. That is equal to V square by R. V square by R. You just equate these values. So you are going to get 15 root 3 by 2, which is equal to V square by R. V square by R. R is 2.5. That's what they're asking. So V square is equal to, can write down 15 root 3 into 2.5 divided by 2. Let's solve this one. So you can write it as a 15 root 3 into 25 divided by 20. 5 3s are 5 4s are. So V square is equal to 25, 3s are 75, root 3 divided by 4, root 3 value is 1.732, 75 into 1.732 divided by 4, then V square is equal to, so if you substitute all these things, we are going to get V approximately equal to 5.69 something, then which is equal to 5.7 meter per second. So these calculations you have to try by your own, then we'll get it. Next, a particle moves in a circle of radius 5 centimeter with a constant speed and time period 0.2 pi seconds. The acceleration of the particle. Super. Question number 40. Particle moves in a circle of radius 5 centimeter. A circle of radius 5 centimeter. Time period is t is equal to 0.2 pi seconds. The acceleration of the particle. Acceleration formula, A is equal to, as it is moving with a constant speed, then what kind of acceleration is 0? Tangential acceleration is equal to 0. Only centripetal acceleration present. Centripetal acceleration is equal to V square by R. They haven't given any information about velocity, so you have to convert that velocity into angular velocity. So we know the relation between linear velocity and angular velocity, that V is equal to R omega, right? Just substitute in this velocity, then what we are going to get, AC is equal to R square omega square divided by R. R will get cancelled. Then centripetal acceleration is equal to omega square R. Omega value also they haven't given, so you have to convert that into the value time period, that is 2 pi by t whole square into R. So they are given some values, so we just have to substitute them. Centripetal acceleration is equal to 4 pi square divided by t square. T value is 0.2 pi. 0.2 pi square is 0.04 into pi square, which is equal to, radius is 5 centimeters, 5 into 10 power minus 2. So pi square will get cancelled. G4 0.01, you can write down 0.01 as 10 power minus 2. If 10 power minus 2 goes to numerator, and that will get cancelled out with 10 power minus 2, already it is there. So answer is going to be 5 meter per second square. So which option matches? Option D is the correct answer. Okay, super. Next, question number 41. So in question number 41, they have given question like this. A stone is tied to the end of a string of 1 meter long, is whirled in a horizontal circle with a constant speed. Okay, if the stone makes 22 revolutions in 44 seconds. Super. So let a stone is tied. Imagine, so a stone is tied here Okay, so length of the string is 1 meter, whirled in a horizontal circle with a constant speed. So it is being whirled with a constant speed. If it is constant speed, what about tangential acceleration? Tangential acceleration is equal to 0. Okay, if the stone makes 22 revolutions in 44 seconds, okay, it means they have given angular velocity. Stone is moving in a circular motion. They have given angular velocity which is equal to 22 revolution in 44 seconds. This is the way you have to represent, which is known as angular velocity. So 22 by 44, it is going to be 1 by 2 revolution per second. So one hint I would like to give is 1 revolution is equal to 2 pi radians. Just remember this. 1 revolution is equal to how many radians? 2 pi radians. Because I need omega in terms of radian per second. That is the reason I am going to convert revolution into radians, which is 1 by 2 into 2 pi radian per second. So this 2 will get cancelled. Omega is equal to 2 pi radian. No, not 2 pi. 2 is getting cancelled. No. So you are going to get pi radian per second. This is the velocity of the object. Now what's the question they are asking? So what is the magnitude and direction of acceleration of the stone? Okay, so for the formula for acceleration, the only acceleration which is present is centripetal acceleration, because this stone is revolving in a circular motion with a constant speed. So tangential acceleration is going to be 0. So centripetal acceleration formula in terms of omega is omega square r. So value of omega is pi square. So it is pi square into r value is 1 meter. So final answer, pi square meter per second square is the centripetal acceleration, which always acts towards the circular motion. Center acts along the direction, along the radius and towards the center of the circular motion, towards center of circular motion. So this is the point we have to remember, circular motion. Very good. So which option matches? So first one, pi square meter per second square and directed along the radius towards the center. First option itself is correct. 41. Clear guys? Yes it is. Second option is also there. Just check out pi square meter per second square and direction along the radius away from the center. No, centripetal acceleration is always towards the center of the circular motion. Remember this. Centripetal acceleration direction is always towards the center of the circular motion. Okay. Next question number 42. So let us see what's they're asking. A particle moves along a circle of radius 20 by pi. Okay. So radius is equal to 20 by pi meter. Next, with the constant tangential acceleration, if the velocity of particle is 80 meter per second at the end of second revolution. Okay, initially you have to imagine initial velocity of the object is equal to 0. They said velocity after second revolution. So velocity is equal to 80 meter per second after second revolution. That means 2 revolutions completed. So 1 revolution is equal to 2 pi r radians. So distance covered, angular displacement covered by this object. So 2 revolution is equal to 4 pi r radians. So this is not angular displacement, this is linear displacement. So this is circumference of the circle, 2 pi r. So it is going to be substituted in meter. It is not angular displacement. Okay. Now what's the question they're asking? They're asking tangential acceleration. Okay. So first of all, find out the what is the displacement covered. So final velocity they have given. So v square is equal to u square plus 2as. Can we use these equations? Yes, we can use this equation because they said constant tangential acceleration. If acceleration is constant, we can use equations of motion. Final velocity is equal to 80 into 80, which is equal to initial velocity is 0. So 2 into a into what's the value of s after 2 successive revolution? It is going to be 4 pi r. So from this acceleration is equal to, so it is going to 2 4 is 8. So here it is 10. Then you are going to get 800 by pi a r. What's the value of radius they have given? 800 divided by pi a. No, why a comes again? No, a doesn't comes. A only I am calculating, right? So a is equal to 800 by pi r. So what's the value of r? R is 20 by pi meter. So pi will get cancelled. 21s are 24s are 80. So acceleration is equal to 40 meter per second square. 42. Option A matches. That is the answer. Okay, next question number 43. Solution. Two particles having mass capital M and small m moving in a circular path having radius capital R and small r. Their time periods are same. Then the ratio of angular velocity they are asking. So this kind of questions already we solved. That is time period t is equal to 2 pi by omega. So t is independent of velocity or radius of the circular path. That's why here t is constant. If t is constant, omega is also constant. Remember this point. So hope you understood. Next question number 44. Two racing cars of masses m1 and m2 are moving in a circles of radius r1 and r2 respectively. Their speeds are such that each makes a complete circle in the same time. Again same thing. So 44 solution time is going to be same, which means time is constant. Okay, then they are asking ratio of angular speeds of first to second hour. Again, as t is the same, omega is the same, then ratio omega 1 by omega 2 is equal to 1 by 1. 1 is to 1 is the ratio. Option C is correct. Next question number 45. A body is wheeled in a horizontal circle of radius 20 centimeter. Okay, they are given circular motion question. Radius is 20 centimeter. Then it has an angular velocity of 10 radian per second. Omega is given 10, how many? 10 radian per second. Okay, so what is its linear velocity at any point on the circular path? Super. What's the relation between linear velocity and angular velocity? Linear velocity v is equal to r omega, right? Then v is equal to r value is 20 centimeter, convert that into meter, 20 into 10 power minus 2 into omega value 10. So v is equal to 0.2 into 10, which is equal to 2 meter per second. So this is the answer, which is option D is correct. Next, it's a conversion question. Next one. So the angular speed of a flywheel making 120 revolutions per minute is angular speed. That's it. Okay, 46 solution. Omega is equal to 120 revolutions per minute. Actual omega units must be in terms of radian per second. We have to convert them. 1 revolution is equal to how many radians? I did explain that is 120 into 1 revolution is equal to 2 pi radians divided by 1 minute is equal to how many seconds? It is going to be 60 seconds. So 60 ones are 60 twos are. So So final answer 4 pi radian per second. That is the answer. Option A matches correctly. Next, question number 47. Let us see what's there asking the question. An electric fan has blades of length 30 centimeter measured from the axis of rotation. Okay. Assume this is a fan. So the length of the blades 30 centimeter measured from the axis. This is axis of rotation. From this point it is 30 centimeter. Okay, next. What they're asking, if the fan is rotating at 120 rpm, so fan started rotating with omega is equal to 120 rpm. Rpm in the sense rotations per minute or revolutions per minute, so you have to convert that into radian per second, so which is equal to 120 into revolution per minute, which is equal to 120 into revolution is equal, one revolution is 2 pi radians divided by 1 minute is 60 seconds, so it is going to be 61s 62s, so you are going to get omega is equal to 4 pi radian per second. This is the angular velocity of the tip. So if the fan is rotating at 120 rpm, the acceleration of a point on the tip of the blade they are asking. Okay, so what's the formula for acceleration? Acceleration is equal to, how to convert acceleration? I'm sorry, I need acceleration at the tip. So the tip point I need acceleration formula. So only acceleration which is present is centripetal acceleration. That centripetal acceleration is equal to omega square r. What's the value of omega? It is 4 pi whole square into r. R is 30 centimeter. 30 into 10 power minus 2. 4 square is a 16. 16 into pi square into 30 into 10 power minus 2. So pi value is 3.14 or 22 by 7 you can write down. If you substitute all those things, we are going to get final answer 47.4 meter per second square. This is the centripetal acceleration of the tip of the point. So here it is, option B is correct. Very good. Next, let's move on to the next question. Question number 48. Solution. What did they give? If magnitude of A bar cross B bar is equal to root 3 times of A bar dot B bar. Okay. Magnitude of A bar cross B bar is equal to root 3 times of A bar dot B bar. Formula for magnitude of A bar cross B bar is AB sin theta, which is equal to root 3 times of AB cos theta. AB will get cancelled out. So sin theta by cos theta is equal to root 3. Then tan theta is equal to root 3 and theta is equal to 60 degrees. Okay. Now what's they're asking by giving this kind of data? They're asking magnitude of A bar plus B bar. Magnitude of A bar plus B bar, we know that is equal to R bar magnitude. So to find out R bar magnitude, it is resultant of two vectors. Resultant is nothing but addition of two vectors, which is equal to A square plus B square plus 2AB cos theta. Theta is equal to 60 degrees here. Cos 60 and 2 will get cancelled out. Remaining answer we are left with, so which is A square plus B square plus EAB. So options are in the form of power. So it is A square plus B square plus AB whole power 1 by 2. This is the answer. Got it? So which option is correct? Option A. Now look at question number 49. A ball is projected with a velocity 10 meter per second at an angle 60 degrees with a vertical direction. Okay. Be careful with the question. This is recent question. So 2022 NEET question. A ball is projected with an initial velocity 10 meter per second. The angle they have given with respect to horizontal or with respect to vertical? With respect to vertical they have given, which is 60 degrees. Okay, now divide two components, horizontal component of velocity and vertical component of velocity. Horizontal component of velocity is 10 sine 60. Vertical component of velocity is 10 cos 60. Wherever theta is adjacent, that component is cos theta component. So here it is 10 sine 60 is nothing but you are going to get 10 into root 3 by 2, which is equal to 5 root 3. So what's the question they're asking? Speed at highest position of the trajectory will be. Okay, so when this object is under projectile motion, which component of velocity is 0 at its maximum height? Vertical component of velocity. Only velocity which is present is horizontal component of velocity. Vertical component of velocity is 0 at maximum height. Then horizontal component of velocity is nothing but 5 root 3. This is the answer which is present at its maximum height. Option 2 is correct. Clear? Okay. Next question number 50. So a bullet is fired from a gun at a speed of 280 meter per second in the direction 30 degrees above the horizontal. Okay. Super. What is the initial velocity? 280 meter per second at an angle 30 degrees with respect to horizontal. The maximum height attained by the bullet is super. They are asking maximum height. So formula for maximum height, h is equal to u square sine square theta by 2g. So let me take g value as 10 meter per second just for calculation, then we can approximate that value. So u square, u value is 280 into 280 into sine theta. Theta value is 30 degrees. Sine 30 is 1 by 2. You can write it down as 1 by 4 divided by 2 into g value. Let me consider it is as 10. So 1 0 will get cancelled. 4 1s are 4 7s are. Then you can write 1 1s are 1 140s. So 140 into 7, which is equal to approximately, not approximately, the answer that I am going to get 140 into 7 is going to be 980. So if you observe the option, this answer is not at all in the option, but we did one thing here. So did I reduce or increase the value of acceleration due to gravity? I did increased. So because g value is 9.8, they have given in the question itself. So g value they have given it is as 9.8, but I have increased that g value to 10. If I increase the g value, that which is in denominator, then what happens to h value? H value decreases. So actual answer is going to be the more than whatever the answer I got. So that is how you have to imagine. Then answer is going to be approximately 1000 meters. So which option matches correctly? Option B matches perfectly. Hope you understood, guys. Try to understand the representation, how I did approximated it here. Next, look at the question number 51. Okay. In 51 question, a horizontal bridge is built across a river. A student standing on the bridge throws a small ball vertically upward with a velocity 4 meter per second. The ball strikes the water surface after 4 seconds. The height of the bridge over the water surface. Okay, super question. So let me explain you that. So there is a bridge. Let me represent here. So here it is water surface. So here water is flowing like this. Okay. So a person throws a ball vertically up with 4 meter per second. Okay, so the ball strikes the water after 4 seconds. The height of the bridge they are asking. Okay, so first this object reaches maximum position. So final velocity when it reaches maximum position is going to be 0. Let me find out velocity or time after which it reaches maximum position. This is case 1. In case 1, initial velocity is equal to 4 meter per second, final velocity is equal to 0, acceleration due to gravity is 10 meter per second square, and use v is equal to u plus at, final velocity is 0, initial velocity is 4 minus 10 into t. So which is equal to 10 into t is equal to 4, then t is equal to 0.4 seconds. Okay, hope you understand guys. It is 0.4 second. That means time taken by the particle to reach maximum height is going to be this height, which is equal to 0.4 seconds. How much time it will take to come back to the same position? It is going to take another 0.4 seconds. Super. So whatever the time it is going to take to reach maximum, it is going to take same time to reach ground. Try to remember that. Okay. Next. So with what velocity you are throwing that object vertically upward 4 meter per second? With how much velocity it is having when it is at the same position, while it is crossing the same position, it is going to have same velocity, which is equal to 4 meter per second. Total time of travel it is completed is 0.8 second. Okay, so 0.4 second to reach maximum and 0.4 seconds to reach ground position. Now the velocity when it is moving down from the surface of the bridge is going to be 4 meter per second. That is the velocity with which it is thrown. Then what is going to be the remaining time? They've already said that. So it is going to hit the surface, water surface, with after 4 seconds. Already 0.8 seconds completed. Remaining time is going to be 3.2 seconds will be there. So that is the time of travel. So 4 seconds is the velocity. Case 2, if you observe case 2, I know initial vertical velocity which is equal to 4 meter per second. Time of travel is 3.2 seconds. Is it possible to find out displacement covered? S is equal to ut plus half at square. So S is equal to initial velocity is u 4 meter per second. As object is moving downward, I must consider it is as a negative. So it is minus 4 into time of travel is 3.2 minus 1 by 2 into 10 into t square, which is equal to 3.2 square. So 2 5s. So final answer S is equal to 3.2 into 4 is going to be minus 12.8 minus 5 into 3.2 square, which is equal to 40.96. So if you add these two values, you are going to get answer approximately 53.76. This minus indicates object moving downward.